All right, so a quick recap. Because of the geologic history of Georgia, we've got four main provinces: the North Georgia Mountains, the Piedmont, the Coastal Plain, and the coast. So we can think about how this geology impacts us as geologists, as people who use earth resources in this state. Right? So next we get to talk about Georgia's geologic resources and the mining industry. We're going to go back to the early beginning of Georgia, starting with the gold rush of Georgia. So the largest quantities of gold found in the eastern U.S. were actually found in the Georgia Gold Belt. In this image, I'm showing you a picture of where gold was found, those really dark veins on top of the North Georgia Mountains and the Piedmont. Notice that the veins of gold are elongated in the same direction as all of the other rock features. And as you would expect, all of the faults, or most of the faults, to also be oriented because of that convergence in the tectonics. And as we know, anywhere you get a lot of heat, a lot of pressure, creating igneous intrusions, igneous events, that will create really hot hydrothermal fluid, which dissolves the gold ions in solution, and then it rises up through those faults, those cracks, and precipitates out as a solid, allowing us to get these gold veins in Georgia. So the discovery of gold in Georgia in 1928 led to what we call the Georgia Gold Rush. At that time, a lot of people came to search for gold, right? So as I just said, gold was found in Georgia due to hydrothermal processes. We had really hot environments because of igneous intrusions, creating hydrothermal fluids with dissolved ions rose up through cracks, crevices, pores, faults, precipitating out those hydrothermal veins. And once those hydrothermal veins were deposited, you could either get the gold right from those veins, or you could wait for those veins to start to erode, turn into sediment, go into the rivers. And that's where a lot of people panned the rivers. So it started as an igneous deposit, but ended up deposited in a sedimentary deposit. All right, so in 1828, more than 10,000 white men descended in Georgia in hopes of striking it rich. But Georgia was already occupied by many native Cherokee families at that time, as was very prevalent in our past. The government, President Andrew Jackson at the time, signed a bill of removal, forcibly removing the Cherokee rights to land ownership, allowing these white men to come in and actually take gold out of the land. The gold rush ended pretty quickly, right? It was a boom. They took a lot of gold. The easy gold was gone, and then that boom stopped. But the removal of the Cherokee families had already begun and was irreversible. So today, even though we no longer have really, really prevalent gold mining, we still have this as a part of our history. And you can go see this history in places like Dahlonega, Georgia. From their website, it says head 200 feet underground and over 100 years back in time to experience life as a turn-of-the-century gold miner. Here they offer mine tours, gemstone mining, gold panning, things like that. Even though the mines are no longer active, you can go see what the mines looked like and what it was like to actually be underground in these shaft mines. Right? Now, mining today looks very, very different than it did in the 1800s. We are no longer mainly mining up in the mountains and shaft mines for gold. Instead, much of our economic resources comes from sedimentary deposits and surface mining. So in 2018, the value of non-fuel mineral production in the state of Georgia was almost $2 billion. The kaolin mining is Georgia's largest export for the last century, and it makes up 91% of all U.S. sales. So Georgia really dominates in kaolin mining. And as we've talked about it before, kaolin is used in all sorts of stuff, but often in paper, porcelain, paint, rubber, so on and so on. So it's very important to the Georgia economy. And again, as we've discussed before, but if you're going to be in Georgia and you're going to be a geologist, you should really know this stuff. The origin of kaolin can be traced back to the Cretaceous geologic period, about 70 million years ago. During the Cretaceous, it was much, much warmer. Sea levels were much higher. So sea level actually made it all the way up to the fall line. And the weathering of the rocks in the Piedmont, you know that mountains are made up of a lot of granite. Granite contains feldspar. When feldspar weathers, when it becomes hydrated, it weathers into clays, often kaolinitic clays. And those clays are then washed down the rivers and the streams, eventually deposited at the fall line where they entered the ancient ocean. And now that the ocean has receded because we're a lower temperature than we were than in the Cretaceous, the kaolin is still deposited at that fall line. And that's where we find it. That's where we mine it. An example of a kaolin mine is here. Again, this is a large open pit mine, no longer those narrow shaft mines going down into the mountains like we used to get the gold.